Many people worry every day how much radiation they're actually exposed to. So in this video, we're going to look at how we measure radiation dosage and have a look at what values are safe.
In this video, we're going to look at ways of quantifying radiation, and once we've chosen a suitable unit, we'll look at values we're exposed to in everyday life so we can get a feel for what is normal, what is considered safe, and what might be dangerous. There are several ways of quantifying radiation. The four key things we need to quantify are activity, exposure, absorbed dose, and the dose equivalent. Activity, as we met in the What is Radioactivity video, is the number of disintegrations per second, which we said was measured in becquerels. The slightly old-fashioned unit is the curie, equivalent to 3.7 times 10 to the 10 becquerels, was originally invented to describe the activity of 1 gram of radium-226, named after Marie and Pierre Curie. Exposure is the amount of radiation travelling through the air, measured in Roentgens. We won't say any more about this as it's not particularly useful in itself for our purposes. The absorbed dose, as the name suggests, is the amount of radiation absorbed by an object, measured in rad, the acronym for radiation absorbed dose, or grays, with a gray being 100 rad. For the most part, 1 Roentgen is the same as 1 rad, but again, this isn't a particularly useful value in itself. The most important unit for our purposes is the sievert, which is a measure of the dose equivalent. This combines the absorbed dose with the medical effects of that type of radiation. For beta and gamma radiation, the dose equivalent is the same as the absorbed dose. However, for alpha radiation, the value is larger, as it is, at close range, more damaging to the human body. Now that we've got a suitable unit, we're going to go on to look at some dose equivalent values, measured in sieverts, to put some numbers into perspective. Here are some examples which hopefully will give you a feel for the amounts of radiation we're exposed to and how that compares to quantities deemed dangerous. These values have been commissioned by the UK government, and please do bear in mind that the numbers presented are in millisieverts, with 1 millisievert the equivalent of 1,000th of a sievert. By eating 100 grams of Brazil nuts, that's about the equivalent of 2 dental X-rays. They're one of the more radioactive foods as the soil where they are grown is rich in radium. Flying exposes you to fractionally more radiation than you would be at ground level, as you are less shielded by the atmosphere from incoming radiation from space. Average exposure to a worker in a power station in the UK is only 0.18 millisieverts per year. Compare that to the annual limit, which is 20 millisieverts. They're approximately 100 times under the set limit. An average person in the UK is exposed to 2.7 millisieverts. Bear in mind this takes into account everything like X-rays, scans, flights, and natural background radiation. In the USA, the average exposure is around 3 times higher than it is for the UK for various reasons. Those living in Cornwall are naturally exposed to more radiation from radon gas released from the local rockery. Again, this is nothing artificial, it's entirely natural. Levels where changes are seen are at about 100 millisieverts, so 30 times above the UK average exposure, although acute effects such as nausea and vomiting aren't seen until 1000 millisieverts, or 1 sievert. Finally, the dose it requires to kill half of those exposed to the dose over the course of a month is 5000 millisieverts, or 5 sieverts. This is an awful lot of radiation, and when you compare the number for the level at which blood cell changes are observed, 100 millisieverts, this is much, much higher than what the average person is exposed to in a year. In our final video, we're going to look at the challenges of nuclear waste and how scientific research is leading to a more sustainable, environmentally friendly future.